Welcome back to another video, and in this video we're going to be moving on from the previous video on expanding brackets. So if you haven't watched the video on expanding brackets, I would check that out now. And in this video we're going to be looking at some more advanced concepts, some more advanced and more difficult questions regarding the expansion of brackets. So if you don't understand the basics, I would go back and check out the previous video first, because this one's for those who want to challenge themselves. Okay, so here we have a diagram that shows a rectangle with a square cut out. So we've got this area in here is all shaded, and then we've got this sort of this square in the middle that has been cut out. The rectangle has a length of 3x minus y plus 4 and a width of x plus 7, and then the square has a length of x minus 2. And we want to find an expanded and simplified expression for this shaded area. Okay, and this is just using the same principles from the last video on expanding brackets. So the first thing we want to do is find an area for find an equation for the shaded area. And we know that if we took the area of the big rectangle and took away the area of the little square, we would get the appropriate shaded area. So don't worry too much about the unknowns, just imagine that these were numbers. If this was, let's say, 10 and this was 5 and then that was just 2, for example, you would know that the area of the rectangle would be 10 times 5, and then you would know that the area of the square is 2 times 2, and you would just take the rectangle and take away the area of the square, which would give you the area of the whole rectangle. Okay, so we're going to apply that very same line of thinking to this question. Okay, so we're going to take x plus 7 and we're going to multiply that by the length here, 3x minus y plus 4. Okay, so that gives us the area of the rectangle. Then we want to take away the area of the square, and we know that the area of the square is both the length times by the width. So that's x minus 2 times x minus 2, or for short, x minus 2 squared. Okay, and now we've changed this problem into a much more recognizable bracket expansion question. And so we're just going to apply those principles that we learned in the previous video. So the first thing to do is to multiply the x by everything in the second bracket here. So that will give us x, 3x minus 9 plus 4. And then we want to multiply the 7 by everything in that bracket as well. So plus 7, 3x minus 9 plus 4. And then obviously we want to expand our squared bracket too. So x minus 2 squared, as I said before, is just the same as saying x minus 2. So now again, we're just moving it closer and closer to a more familiar and more easily understandable equation. And so now what I want to do is to expand this out fully. So we've got 3x squared minus xy plus 4x plus 21x minus 7y plus 28. Okay, and be careful with a negative symbol. People can get tripped up by this sort of thing, but here we got negative x squared, because we've got x times x is x squared, but obviously it becomes negative. We got x times minus 2, which is minus 2x, but minus 2x multiplied by negative 1, you could imagine there's like a little 1 there, makes that positive 2x. And then we've got the same thing again, minus 2 times x is negative 2x times minus 1 makes 2x. And then finally we got minus 2 times minus 2 makes positive 4, but then multiply that by minus 1 makes minus 4. And then all we want to do at this point is to simplify down our equation into its most basic form. So we've got 3x squared here, and we've got a negative x squared there, which gives us 2x squared. And then we've got 1 negative xy, so let's just add that in there like so. And then we want to find the x's, so we've got 21, 25, 26, 27, 28, 29, so we've got plus 29x. And then we've got just 1 negative 7y, and then we just got to count up the final few numbers, which is 28 minus 4, which gives us 24. And therefore that becomes our answer to the question. Okay, this is the simplified equation, the simplified expression, sorry, for the shaded area above. So in this question, it says a cuboid has dimensions x plus 2 centimeters, 2x minus 1 centimeters, and 2x plus 3 centimeters. Show that the volume of the cuboid is 4x cubed plus 12x squared plus 5x minus 6 centimeters cubed. Now the first thing I would do is just try and imagine a cuboid and how we would come about the calculations. Now I'm going to try and draw a cuboid. It might not be very good, but obviously it would have one sort of square front to it, and then we have this sort of like extra dimension at the back. And obviously this is a very bad drawing of a cuboid, but we have this sort of front direction here, we got this upwards direction and this backwards direction too. So we've got 3 separate dimensions, and we know that if we label these x, y and z to find the volume of this cuboid, we'd go x times y times z, okay? And that would be our dimensions. So we're now going to apply that thinking to this question. Okay, make sure you pause the video if you want to give it a go yourself, because I'm just going to continue speaking and answering the question. But it's always good to give it a go yourself first before I actually explain the answer. But let's go straight into this one. So if we're going to apply that reasoning and we're going to give each of these dimensions, let's say x, y, and z, we know now we're going to multiply each of these out together. So what we're going to do is going to go x plus 2 centimeters multiplied by 2x minus 1 centimeters multiplied by 2x plus 3 centimeters. So we've already changed this expression into a bracket expression that we are familiar with from the previous video. And like I mentioned in the previous video, if you get 3 expressions in a row like this, focus on just 2 of them at one time. So we're going to focus just on the first one, and we're going to expand that one out now. And if you did this properly, you're going to get 2x squared, and always try and keep it inside the bracket so you know where you are, and you're not going to end up multiplying the wrong things. You ensure you keep the relevant expressions within the brackets themselves. So 2x squared minus x plus 4x minus 2, and then we obviously still haven't dealt with this equation yet, so let's just stick the 2x plus 3 on the end as well. And then what we can do is just simplify this down, and that will give us 2x squared plus 3x minus 2, and then 2x plus 3. So that is our slightly simplified expression. And then all we want to do now is multiply each of these numbers in our first bracket by each number in the second bracket. So this will give us the following equation. We'll have that is equal to 2x squared 2x plus 3 plus 3x 2x plus 3, and then minus 2x plus 3. Okay, and then as we did in the previous question, we just got to expand it out. Now this can seem like a long, tiresome process, but the more sort of methodical you are about how you approach the questions, the less like you are to trip up and make a silly mistake. So let's now expand this question into its full simplified format. So we've got 4x cubed, multiply those out, plus 3 times 2x squared is 6x squared, plus 3 times 2 is 6, times x is x squared, 3x plus 3 is 9x, minus 2 times 2x is minus 4x, minus 2 plus 3 is minus 6. And then all we need to do now, always at the end of these expressions and all the way at the end of doing a bracket expansion, is to find the like term. So that will give us our final answer of 4x cubed, as we only have one x cubed expression. Then we find the like x squared term, so we've got 6x squared plus 6x squared, which will give us 12x squared. Then find 9x and 4x are like terms, so 9 minus 4 will give us 5, so it gives us plus 5x, and then we got the negative 6 at the end. So then that will give us the answer to that question. Now this is the last question that we're going to do here, so let's try and do this one. It's a little bit more challenging. Now it's expand and simplify x plus y to the power of 4. There is something called a binomial expansion that will allow you to expand expressions like this more simply, but we're simply going to use the method of expanding brackets to answer this question. But once you get to binomial expansions, you will find this far easier to complete. But for the minute, let's try and do it the normal way. So the first thing that we're going to do is work out, what is this trying to tell us? What is x plus y to the power of 4? And that is just x plus y written out 4 times. So x plus y multiplied by x plus y multiplied by x plus y multiplied by x plus y. Okay? And this may be the first time we've come across four brackets that we need to expand, but the same principles apply. Let's multiply 2 brackets at a time. And we know that whatever that expansion is the same as that expansion. So this expansion here would be x squared, and remember to keep it in the brackets, plus xy plus xy. So remember, x squared, x times y, y times y, it's y squared, and this expression is the same as that expression, so we can just write that out again. So x squared plus xy plus xy plus y squared. Okay, and then we can simplify whatever terms we have in the bracket so far. So we know we've got 2 xy's here, so that must be 2xy, and we've got 2 xy's over here, so that's 2 xy's again. So that is the same as saying x squared plus 2xy plus y squared, and then obviously x squared plus 2xy plus y squared. And then now we've got just 2 brackets, so we've moved from 4 brackets to 2 brackets, and increasingly it gets to more recognizable areas that we've dealt with before in the previous examples. So again, the process would be to multiply each one of these numbers by each of these numbers in the second bracket. So we can write out this equation as x squared plus 2xy plus y squared plus 2xy x squared plus 2xy, and that's getting a bit small, my handwriting, because I've realised I'm running out of space at the end here, plus y squared x squared plus 2xy plus y squared. Okay, so we just expand, multiplying each of these first numbers by the numbers in the second expression. And at this point, we now need to fully expand this equation, but this should be much simpler because we've now given ourselves 3 more simple expressions to deal with. But what I would note is, if you haven't watched my video on index laws and you don't know how to multiply indices, I would recommend you check out that video, because at this point you would be having to make probably slightly more complex indice multiplications. Not that difficult, but perhaps a little bit difficult if you're starting out. So x times 2 to the power of x times 2 is just x to the power of 2 plus 2, essentially. So you've got x 2 plus 2, and therefore that would equal x to the power of 4. And then we've got 2xy times x to the power of 2, so we've got plus 2x to the power of 1 times x to the power of 2 will give us x to the power of 3, and then y. And then I'm just going to continue expanding, but if you have any questions about this process, please let me know. So x squared y squared plus 2x cubed y plus 4x squared y squared plus 2xy cubed plus x squared y squared plus 2xy cubed plus y to the power of 4. Okay, so I think that is all correct. And then, so here we've got a really long sum, obviously, but that's the best way we can do it when it comes to expanding brackets. Obviously, if we did it through a binomial expansion, it would be much easier. And you can probably already notice that there seems to be some sort of pattern here with these powers, and that will become more obvious when you do the binomial expansions. But if we then simplify this sum and collect all the like terms, we end up getting x to the power of 4 plus 4x to the power of 3, yep, y, and then we got plus 6x squared y squared plus 4xy cubed plus y to the power of 4. And that will give us our final answer. And you should be able to therefore see this sort of pattern running across here. So x to the power of 4, x cubed y, x squared, xy cubed, and y to the power of 4. And that is that expansion. In the next video, we're going to be looking at factorizing and how that differs to brackets. But if you have any questions about this video, leave a comment below and I'll get straight back to you. Thank you very much for watching.